Hey, Epic. Welcome to Science. Last week in Science, we discussed the human eye and how it works. Let me project a little image. This is the human eye. Remember, we talked about the path that light takes through the different parts of the eye so that it is turned into electrical signals and then sent to our brain and processed into the images that we see every day. Now, today we're going to go a little bit deeper into how an eye works, but we're going to be looking at it a little differently. So humans, as we discussed, don't have very good night vision, right? When we're in the dark, it's really hard for us to see, especially colors, but that's not true of every animal. Many animals can see just as well in the dark as they do in the light. So my question for you is how? How do animals see in the dark? I want you to take a moment before we go any further. Please get a piece of paper and something to write with, and I want you to write down a prediction. Maybe pulling off some prior knowledge that you already have, thinking back to what we talked about last week. And I want you to write down how animals see in the dark. I'm going to leave this up because as scientists, I want to make sure that we're using some of these scientific vocab words in your writing. It doesn't have to be a lot, a few sentences, but let's all take a moment right now to really think critically about what we've learned so far and make a prediction of how these parts of the eye help animals see in the dark. So I'm going to go get a piece of paper and a pencil. I'm going to give us all the few minutes to do this before moving on with the video. So go ahead, paper, pencil. How do animals see in the dark? Go. All right, I have my paper and my pen. Let's take some time to write down how animals see in the dark. Remember, it's okay if you don't know. This is just a prediction. I want to see how you guys think about it before I tell you the answer. Okay. All right, Epic, if you need more time, that is a-okay. I'm not rushing you. Pause the video now if you're not done writing. Go ahead and pause. If you are done writing, then let's move forward. But be honest, if you're not done, pause the video. Don't get the answer before you're done writing. If you are done writing, let's move on. So, how do animals see in the dark? In order to answer that, I'm going to go back to the video that we watched on Thursday of the cow eye dissection. Now, thinkers, I don't think you watched this, but the problem solvers did. And we noticed one big difference between the cow's eye and the human eye. And that is this right here, the tapetum. Let's listen and learn.
If you look at the back of a cow's eye, it almost looks like a shell. That's because cows have a tapetum.
Tapetum. I'm sorry, I mispronounced it. Tapetum.
And I'll flip it out so we can get a better look. If you ever see cats at night, their eyes appear to glow. That's because light comes into the eye and bounces off the back of the tapetum. Humans don't have this. The back of our eye is black to absorb light. And this is the end of our cow eye day.
So the tapetum is the part of an animal's eye that helps them see in the dark. It's a reflective piece right on the back of their eye that reflects the light coming in. So let's review and go through the path that the light takes, right? So first, the light comes through the cornea, right? Through the pupil, and the iris makes it bigger or smaller, through the pupil, then it hits the retina, right? Now, in animal eyes, the tapetum reflects some of that light back onto the retina, giving the retina a second chance to take in that light. So in the end, it ends up seeing a lot more. So that reflective little bit in the back of the eye is why you see animals' eyes glowing. Like, have you ever like looked at your cat or a dog and seen that their eyes are glowing like this? That's because you're seeing the light reflect off of their tapetum and back to you. Now, there are other adaptations that animal eyes have that make them different from human eyes. For example, sometimes the pupil will dilate or get bigger, more so than it would on a human, letting more light in. But there are other adaptations that animals have when it comes to their eyes. And to talk more about that, I'm going to begin a read aloud. So get comfy, make sure to pay attention. This is fascinating. And bring any observations or questions you have about this book to Zoom. What if you had animal eyes? What if one day, when you woke up, the eyes on your face weren't yours? What if overnight a wild animal's eyes took their place? Chameleons. Now, a chameleon's eyes stick out like twin telescopes. These cone-shaped bumps are actually fused together eyelids that are open just enough to peek through, and this limits the chameleon's view. But these eyes can do something tricky. Each eye moves separately. That way, the chameleon can look for prey, such as crickets, in two directions at once. Fact, when a chameleon spots prey, it focuses both eyes on it. That way, it doesn't miss catching, a meal. If you had chameleon eyes, you could look around the toy store fast to find exactly what you want. Ooh, golden eagle. A golden eagle has laser sharp vision. This bird can see up to 8 times better than most people. It can also spot its prey up to 2 miles away. In a flash, the golden eagle can shift its eyes from focusing on something far away to something up close. This is perfect for keeping an eagle eye on and catching a fast-hopping rabbit. Fact, a golden eagle's eyes have a third eyelid that sweeps across the eye like a windshield wiper, keeping them clean. If you had golden eagle eyes, you could sit up high in the stadium and still see the football game. What about a dragonfly? Oh, those are some cool eyes. Dragonflies' eyes are huge. And they have to be, because each dragonfly eye has up to 310,000 tiny lenses. The human eye only has one. Scientists aren't sure how a dragonfly's brain creates images from all those lenses, but they do believe having so many lenses lets the dragonfly spot movement fast. That's how a dragonfly can see a flying mosquito in time to catch it. Fact, a dragonfly has 3 small extra eyes that help guide its flight path by sensing bright light in shadows. If you had dragonfly eyes, you would be a star reporter because you'd never miss any of the action. Ooh, a clouded leopard. A clouded leopard's eyes have a special mirror-like layer at the back. What's that called? Bring your answer to Zoom. This layer reflects light back through the retina, the part of the eye packed with light-sensing cells. This helps the clouded leopard see well in the dim light at nighttime. That mirror-like layer, the tapetum, is also what makes the clouded leopard's eyes seem to glow. Fact, the clouded leopard has slit-shaped pupils opening where light enters the eyes. These can expand about 100 times to let more light in. A human's round pupils only expand about 10 times. So not only does the cloud leopard have a tapetum in the back of their eye, but their pupil can expand way further than ours can. Fascinating. If you had clouded leopard eyes, you'd never be surprised in a dark, haunted house. Ooh, a bullfrog. A bullfrog's eyes are on top of its head so that the frog can hide underwater and still watch out for enemies. Its eyes are also wide apart. That way, the bullfrog can see nearly all the way around itself without turning its head. But these eyes help a bullfrog do more than just see. When a bullfrog swallows, it closes its big eyes. Its eyes sink down through openings in its skull and help push meals down its throat. That is so cool. Fact, a bullfrog's eyes have a third see-through eyelid. When a bullfrog dives underwater, these eyelids slide over its eyes, the perfect built-in swim goggles. If you had a bullfrog's eyes, a blink would let you swallow a big bite. Oh boy. Can you imagine your eyeballs going in your skull and helping push food down your throat? That's crazy. That's so cool. How about a four-eyed fish? Ooh, that is so cool. A four-eyed fish really has only 2 eyes, but each eye has 2 different parts. Each of these 4 parts has its own pupil. This fish keeps half of each eye underwater, looking for insects and smaller fish to eat. It keeps the other half of the eye above the water, watching for birds and other predators that are after a fish dinner. That is so cool. Fact, 4-eyed fish usually travel in groups called schools, so there are always lots of eyes watching in every direction. If you had 4-eyed fish eyes, you could read while riding your bike and never take your eyes off the road. My mind is blown. That's so cool. Let's read a few more. Yellow mongoose. A yellow mongoose's eyes have rectangular pupils. These give it a very wide view of its world. That means the mongoose can easily spot insects and lizards to catch and eat. It also keeps watch for hunters, such as jackals, sneaking up from the far left or right. When there is danger, its special eyes also help it spot escape routes. The yellow mongoose is mainly active during the daytime when it can see best. Fact, to see farther and peek over bushes, the yellow mongoose stands up tall on its hind feet. If you had yellow mongoose eyes, you'd always win at laser tag. Let's do one more. Oh, cool. Colossal squid. The colossal squid has the biggest eyes in the world. Each eye is as big as a soccer ball. At the back of each eye is a part that produces its own light. It's like having a built-in flashlights that are always on and glowing brightly. This makes it easy for the colossal squid to find fish to eat, even though it lives deep down in the ocean where it's always dark. Scientists can't take photos of living colossal squid because they live so deep underwater. Our closest peek is seeing their cousin, the giant squid, but their eyes can't produce light. Whoa. If you had colossal squid eyes, you could go on a nighttime hike without a flashlight. See how her eyes are acting like flashlights? That is so cool. I guess there is more of this book, but for the sake of time, I'm going to pause now and I'm going to explain what we're doing on Zoom today. So once we get back, we're going to review the parts of the eye and talk about the tapetum a little bit more. And then, just like the kids in that book, I want you to choose if you could replace your eyes with any other animal's eyes. Which animal would that be? Come to Zoom with a paper and a writing utensil. Be prepared to write a little bit defending, explaining which animal you chose. And I can't wait to see them. It's going to be a good time. So either me or Megan will see you soon on Zoom. Bye, Epic.